Let's take a look now at a system of equations that has infinitely many solutions. With an infinite system of equations, you will have two lines that exist on the same line. These systems have all the same solutions and they are infinite. These systems are called consistent or dependent systems of equations. Let's look at an example, graph your work, and also solve by elimination. So we have x plus y equals 4 and 2x plus 2y equals 8. I'm going to move these over so that they are in slope-intercept form. So in the first equation, if I subtract x on both sides, we're going to get y equals negative x plus 4. And in the second equation, if I subtract 2x on both sides, I get 2y equals negative 2x plus 8. And I need to solve for y, so I'm going to divide both sides by 2. And then my algebra teacher would shout, "I heart algebra" to the class, and we would get negative x plus 4. So notice that when we put these in slope-intercept form, we actually get the same equation, even though the original two equations look slightly different. So we have a y-intercept at 0, 4, and our slope is negative 1 because there is a negative sign in front of the x, so it's negative 1, and we could think about that like negative 1 over 1. So we'd move down 1 unit, right 1 unit, down 1 unit, right 1 unit, so on and so forth. And so I would connect those ordered pairs. So that was this first line here, and then I want to graph the second line as well. So I'm going to graph that in a different color. And if I do that, then it's going to look something like that. And these lines are exactly on top of each other. So there are infinitely many solutions. And we just need to find ordered pairs that satisfy that equation. Like notice this is an ordered pair on our line, and that ordered pair is 1, 3. Let's just plug that into one of the equations just to make sure that it actually is true. So the y value is 3 and the x value is 1. Does that end up being true? Well, on the right-hand side of the equation, negative 1 plus 4 is in fact 3, so we get 3 equals 3, and it checks off. So 1, 3 is a solution. Notice that we have this other ordered pair here, 2, 2. That's also a solution. 0, 4 is also a solution. So it turns out there are infinitely many solutions to this system of equations. Now, let's move back to looking at the original two equations and think about how we might have solved this using the elimination method. So I'm going to multiply the top equation by 2, and if I do that, my new equation becomes 2x plus 2y equals 8. And notice that that is the same equation as the bottom equation. So if I subtract these, I'm going to get 0 plus 0 equals 0, or just 0 equals 0. And when is that true? Well, that's always true. So that's what tells us that there are infinitely many solutions to this particular system of equations.